The universe is just a box filled with prison rocks. We're lost in the stocks, each soul part of a flock. So you think you know reality? It's not what you can see. Your life is like a tree that's adrift in the Black Sea. The universe is just a box filled with prison rocks. We're lost in the stocks, each soul part of a flock. The illusion has lots of clocks. The devil is one sly fox. Each door has a lock, because the universe is a box. The universe is just a box filled with prison rocks. We're lost in the stocks, each soul part of a flock.
This is Dr. Adoni. My site is soladoni.com. That's SOLADONI. I've written quite a few books over my career, over 100 of them, a lot of theories in math and physics. And today I'm going to discuss the hothouse effect theory as it relates to dinosaurs. My new book in site is called hothouseeffect.com. You can see the book has a picture of a dead dinosaur on it. Also, another site I have related to this is whatkilleddinosaurs.com. whatkilleddinosaurs.com. And again, same picture of the dinosaur who died. Basically, most scientists agree with the so-called asteroid extinction theory. There's a lot of holes in that theory. Why did smaller mammals survive? Why did certain fish survive? Why did a lot of plants survive? So even though large land animals did pretty much have an instant die-off in the geological record, such as dinosaurs, larger mammals, a lot of life survived. Now, to me, the most interesting thing about this period in time is the very high CO2 level, which is 10 times what our current level is. That was the CO2 level when this mass extinction event happened. We're currently around 400 parts per million. Before the industrial age started, we were a little bit under 300 parts per million. So, especially since the 1950s, the ppm level of CO2 has risen significantly. We're nowhere near the 4,000 level, and a lot of people that are into the global warming phenomena. Field 900 ppm is a death zone based on incorrect data in the fossil records. They cite 900 ppm from the Triassic so-called extinction event. The only problem with the Triassic extinction event, it took many millions of years, and the breakup of the supercontinent into our current continents for all these animals to die off. And it was about 90% of animals disappeared from the fossil record. But it's not almost instant like the Cretaceous extinction that killed all the dinosaurs. The Triassic extinction was, to me, more like evolution. And there's a lot of other scientists that also agree. The extinction in the Triassic wasn't really an extinction because it took too long. It took many, many millions of years, and that's more in line with evolution than an extinction event. So it might be that 900 ppm, yeah, it would make a significantly warmer Earth, and a lot of coastlines would change, and most of our old ports, like New York City and London, all those things would go underwater. But it wouldn't end most life on Earth. Most life didn't have a significant problem surviving on Earth until we hit the 4,000 ppm levels. And that's when the temperature would have been over 120 degrees, and surface animals and surface fish that couldn't adapt to warmer water would have died in significant numbers, as the fossil records show. So, well, what caused the Earth to get so much carbon? Well, the simple fact is it was the high growth of these huge dinosaurs. The Titanosaurus was 100 tons. That's like if a human averages 200 pounds, okay, it takes 10 humans to make a ton, so it would be 1,000 humans. And a human, through respiration, puts out 2.5 pounds of CO2 a year. I mean, a day, almost a half a ton a year just breathing. So when you have these animals who were egg layers that could mass produce in high quantities, okay, putting out 1,000 times what a human puts out. I mean, these huge dinosaurs were literally walking CO2 carbon plants. You know, they were huge, putting out 1,000 times what a human puts out in a day. So 2,500 pounds, over a ton a day of CO2 was coming out of these larger dinosaurs. And significant amounts were coming out of the smaller dinosaurs, who were also very large. Not as big as the biggest ones, but, you know. So it was just the natural population growth of these huge animals that were emitting tons and tons of CO2 that created what I call the hothouse effect. And in history of science, you know, this period was often referred to as the hothouse period. Okay, so the greenhouse is more of a modern concept connected to pollution and other gases. But the CO2 was for a long time called a hothouse effect. Okay, so the Earth, you know, had these animals producing CO2, plants thrived on it, and all kinds of new plants and trees evolved that were putting out purer and purer oxygen levels. So the high, rich oxygen and abundant food and plants fueled the growth of these huge dinosaurs that were herbivores. And they fueled the whole food chain. You know, when you have high levels of pure oxygen and lots of food, yeah, animals got huge. So it was the successfulness of the dinosaurs becoming so dominant and so big that created the abundant CO2 levels, which manifested in extreme rises over millions of years to a level when all of a sudden, you know, surface life just couldn't exist when it reached a certain temperature that took millions of years to get to. And that's why you see that a lot of animals that could burrow into the earth, smaller mammals and things, they had no problem surviving the hot surface, okay? Just like fish that could go into deep water had no problem surviving hot water. Fish that couldn't get to deep water, that couldn't handle hot water oceans, well, yeah, they perished. But a lot of life survived. So that's my theory of the hothouse effect. My book explains it more, shows a lot of graphs with the levels throughout histories, and it definitely questions the extinction period in Triassic, that it was evolution, not extinction. And yeah, asteroids hit all the time. Humans have survived them. Other animals have survived them. The asteroids aren't as big as a deal as the CO2 level coming from just the animals who were large, emitting, you know, a ton of CO2 a day. So that's what rose the CO2 to a 4,000 ppm level, and that's what created the jungle heat that just made most animals keel over and die. It was just simply too hot. Their respiration couldn't work, you know, over 120 degrees. It's like today, you know, you put an animal out in 120 degrees, they die. It's just too hot. So did it reach 120 degrees? Well, maybe these big animals couldn't survive 100 degrees. Okay, so I'm not exact on exactly what the temperature was, but 4,000 ppm would be a very hot Earth compared to what our Earth is now. So that's my theory. It's called hothouse effect. You can go to hothouseeffect.com or whatkilleddinosaurs.com, and the theory is fully put forth there. You can get a copy of my book, and explains it in greater depth. This is Dr. Saul Adoni from sauladoni.com. Have a great day.